as partial fraction over x minus 3 squared. So to do this one, here's what you do. You get this one, you repeat the same. That's what, then you are good. So when the square is outside, you express it in this form. Okay? Clear? That's what we do. Okay? So get the 3x. So get the a. Ignore what is under a. Ignore what is under a. Now here's the thing. We usually, when we say ignore, we mean this, they have the same common denominator. But here the common denominator is what? Is x minus 3 squared. So divide this into this. What do you remain with? You remain with x minus 3 plus b. If I divide this one into the denominator, this one, I'm just getting b. So that's what I usually say when you say ignore. For this kind of stuff where they are squaring each other like this, you just ask yourself, what's the common denominator? The common denominator is this. Begin dividing. All right. So the common denominator here was this for both, because meaning this is the common denominator. Okay. So divide this one into this one, you remain with one of the kind. Divide this one into itself, you remain with one. Okay. So here is what we do. We are going to expand a bit here. Okay. Just expand here a bit. Get 3x equal to ax minus 3a plus b. Now here, what we're going to do is that equate the parts. So 3x has got x, so equate together with that one. Okay. Then can you see any constant here? No, meaning the constant is 0. So negative 3a plus b should be what? Equal to 0, because we don't have a constant on the left side. We have a equal to 3. Okay, that's what it means. If you know what a is, you can find b. Okay, negative 9 plus b. And b is what? What is b? 9. So if I come here, my a is 3 over x minus 3 plus 9 over x minus 3 squared. You're done. Next up, let's do it. It's very simple. A over, there's a square here, so we'll say a, b, then c, x plus 1, in case you're wondering. Remember, this is a square, same way we treated this one here. Okay, let's now do it. So our common denominators here, okay, our common denominators, they are these both. All right, so just get 4x squared plus 2x minus 1, say equal to, divide this, okay, this one into here. What do you mean with? You remain with a x plus 1. Then b, divide x squared into this denominator, it remains what? X plus 1. Divide this into here, you remain what? X squared. That's all. Then 4x squared plus 2x minus 1, expand. If you expand, you get ax squared plus ax. Multiply here, you get bx plus b plus cx squared. Group those with squared together. Group them with those squared together. There is a and c, meaning x squared is common. Meaning I can factorize the x squared, so I have a plus c and x squared. There's x and x, group them together as well. So I've got a plus b. Then take the x out. Then plus b. Check out that this and this are in the same form. So what has got x squared? You group them together. So for x squared, you say is equal to a plus c x squared, like that. Okay, cancel this. You have 4 is equal to a plus c. You keep this as your first equation. Second equation, we get the 2x is equal to a is equal to this one, x. When the x is gone, you have 2 equal to a plus b. Keep this as your second equation. We are going to solve them simultaneously. The other one is, this one is a constant, so negative 1 is equal to b. At least we know that b is equal to negative 1. So starting. Here we can find a, since we know that a plus b is equal to 2. So b is negative 1 equal to 2. So a is equal to 3. Can we find c? We know that a is 3, because we know that 4 is equal to a plus c. This equation here. And a is 3. 3 plus c. Okay, taking 3 the other side, it gives us c as 1. Then let's now write this as the partial fraction, meaning the partial decomposition, a over x. What is a? A is 3. So you put 3 over x. Are you there? Minus. Why am I putting minus? Because b is minus. So 1 over x squared plus 1 over x plus 1. Next, let's look at this one into partial fractions. What we can do here, ladies and gentlemen, is maintain what we have first. Check out that something can be factorized here. X squared plus 1. Now, here is what I want you to pay particular attention. This will be a over x. Or how are we going to write this one? The question is, can you factorize this part? This part is not factorizable. Okay? Because the part is not factorizable, here's how we write. We write like this. Because they are not reducible. Are we there? You can't reduce them. So you add x to one of the coefficients, then you add also another coefficient. Okay? Now, let's do the closing of multiplying now there. We are going to maintain our x squared plus 2x plus 3 equal to. So if I get a, okay, if I get a, because all these are common denominators, I'm going to just get this side. Because if I divide x here, I remain with x squared plus 1. Plus, then you have bx plus c. So bx plus c, if I divide this into here, I remain with x. Expand. Expand. You get ax squared plus a. X times bx, you have bx squared plus cx. So you know that x squared and x squared can go together. So factorize the x squared, you have a plus b. Then you have cx, and you've got a. So this part should be equal to this part. So we say x squared is equal to a plus b x squared. Cancel the x squared, you have 1 equal to a plus b. Keep this. Next, 2x should be equal to cx, and our c is 2. C is 2. Next, the constant should be equal to the constant. So a is 3. Okay, this one is already given, right? A constant, you equate to the constant, you are good. So we know what a is. We know what c is. Can we fail to know what b is? Because from equation number 1, we know that 1 is equal to our a is 3 plus b. Meaning if I take 3 the other side, this becomes negative 2 equal to b. Now, can you fail to now just substitute there? Which I doubt that you can. So you have 3 over x because a is 3. Then here, what are we going to have here? We're going to have a minus. On b here, because b is negative 2. So we're going to have plus, then we have minus 2x plus 2 over x squared plus 1. Have you seen how I'm writing? The negative here is still attached there. And this plus is the plus from here. And you are done.